Hey, what's up, everybody? It's Liv, and today I'm gonna be looking at trees. All right. So, what is a tree? A tree generally it's an array of nodes, and it's laid out in such a way that you have, say, node A here, right? And the node has a list of other nodes. Okay. And so you have one node here, and it has a series of children, who in turn are nodes. And so they can have children as well. So here we have B, and here we have C. And then say here we have D, and D has no children, right? So that's the concept of a tree is actually just a sequence of nodes. Okay. So what defines a node is just this type of structure, which if you have trouble visualizing it as something practical, think of how do you say files, right? So when you look at like a file structure, like a file system, that's a tree, right? So that's a practical application. Another practical application is for parsing. Okay, so this is something I'm both experienced in it, but also a little bit of a novice at it, and I'm going to elaborate on that. So the reason why is abstract what they call an abstract syntax tree. I don't know why they make up these dumb names for things that are so simple, but anyhow, I always thought that this obsession that a lot of developers have with sort of like really common interview questions, things that you get asked all the time because someone decided it was an important part of the curriculum for some course or university or whatever, and a lot of the time uh, it's a lot of theorizing over absolutely nothing and applying nothing, right? So it's like when they teach CS students about classes, and it's always, and you've obviously seen this, it's always class student or or class employee, right? And it always has like email and shit like that, like useless fucking shit that does nothing, you know. um so I was skeptical of, do I really need to learn about trees? So I was doing parsing in a not so straightforward way. And when I realized that I could use trees, I said, well, there is something to this, because take this expression right here. So the way I want to break it down is it's one element here. Then I want to take whatever is separated by spaces and take what's separated by commas, slap it all together, right? So if it's separated by a space that's not followed immediately by an operator, then I want to split, right? So this is one field, this is another field, this is another field, right? And if you take it this concept into trees, say I want to say that my tree should be value declaration, and then we have two fields, right? Oops. And so we have the field xy, and then this little operation in here, right? And then we want to further subdivide that, right? So we want to have, and here we're gonna say field 0. That's the first one. And here we have x, and then we have y, right? Makes sense. And then here, well, we have to do a little bit more work, but yeah, we can break that down as well. So we can have this as that, and this is yeah, right, we have to do 2 and then 3. Okay, right? And so then we have to further subdivide this one. because we have some operations in here, right? So this square brackets thing is actually a point to the reference. I'll explain. I'll further elaborate later, but you know, just so you know, it's the reference. Okay, so anyhow, um, I changed the tab to check if I was recording, and I didn't look at the field. You know, it's right there. Okay. So anyhow, yes, I am recording. So um well, the point is you can just, you know, recursively break this down, and then just, you know, when you're trying to make sense out of that stuff you broke down, you have it organized in such a way, in this hierarchical way, that you can take one element at a time and you know, and then look at it, what it's all about. So it's a very neat way of classifying, right? So this, I guess, would be some kind of syntax tree. I don't know if abstract or what. Honestly, the classification is meaningless, absolutely meaningless. The point is the practical application and how you can use this to solve problems. And this is a very good way to solve this kind of problem of having to parse this kind of string, detailing commands and whatnot. So yeah, I already have this thing implemented, so to speak, and we're gonna look at it, and you can see, you know, it kind of breaks it down, but not quite, right? So we still have to do this part right here. So we want to break this into a group, right, into a field, and actually, I did do it. Give me a second. I did do it. I did break it down. So, oh, because it's reorder, right? So it's a group, then reorder. Okay. To exp a group. All right. And now you can see it. It breaks it down further, right? Breaking at the commas. So now what we have to do is we have to break down this part right here. So I already have the operation solving, so that's trivial. Not really, actually. I can show you how trivial it actually is, or at least my implementation. This collapse right here. Yeah, this is a little bit crazy. Yeah, and you know, it's I'm kind of proud of this function because it's recursive. It will solve the operations recursively without calling itself multiple times. So what it does is it swaps out the current instance, because this is a class. It swaps out the instance, you know, without having to call the function itself. So it's a recursive function that's not being recursive. How do you do that? Go to. That's how the fuck you do that with go to. Okay. So this is why languages that do not have go to are, you know, just inherently inferior. No, just kidding, but not really. Go to is a good tool. Jumps within code are useful. You'll be a goddamn idiot if you didn't think that, and that's all I'm going to say on the matter. Okay, so how do you say, controversial opinions, but this is not controversial. This is just factual information, and you can take it from me and you can quote me, because I said that and I will stand by that statement until the day I die. Jumps within code are good. If you do not know how to use them properly, that's on you. Okay, it's not on goto. So anyhow, we have another one of these. So yeah, we have to run both of these, the subdivision and the collapsing. Okay, so because as you can see here, this is not ideal, this format. What we want to do is we want to know what the operation is, and then we want to know what the operands are, right? So in this case, it's true, it's 3 and 2. So for addition, this is not important. But if we had a subtraction, then it is important, right? Because it's not commutative, right? Is how you say it. With division, same thing. Modulo implied division. Multiplication is commutative. Well, anyhow, and if you're calling a function, right? Because that's another thing we can do with this. Say we have a function, and argument A, suppose its name, and argument B, suppose it's a pointer. Can you get these two mixed up? No, you cannot. And so, right, the order of the operands is important. So anyhow, we do have to break these things down so that the function, or the function, the procedure that we want to call the instruction, is the first thing, and the arguments after that. And that's what this subdiv function is doing. But what it does not do is break down the limiters, the square brackets, and the parentheses, right? So what I think braces is what you call these, parentheses, right? The parents. So suppose we had the expression, I don't know, money and kush, right? What we want to do, money plus kush, right? I know, I think you call this hashtag, is that? Yeah, I think that's right. So anyhow, what we would like to do is to break this down so that, and actually it would be like this. And we have money, push, and then here it would end. Okay, right? So you have something kind of like this. Okay, something kind of like this. And it's not very difficult to do this breaking down. Matter of fact, I've already coded it. Yeah, but I had to solve a little problem in that so let me phrase it like this. If I break down this first thing, then this is going to result in a multitude of nodes, which means that when I try to break down into multiple nodes based on commas, then it gets more messy. So what I want to do is break down into by spaces first, then iter through all the nodes that I have and break down by commas so that I can get the fields right, and then break by parentheses, right? So that's a little bit of what we have to do. So I've already coded the break by delimiter function. This delimiter in the sense of parentheses and brackets and square brackets, as you call them. So I've already written this, but what I need to do now is sort of look at all the how do you say this? Look at each field with each node within each field. Walk this hierarchy, and if I detect these how do you call them? These square brackets. Oh, language trouble. Okay, so when I detect any kind of delimiter, break this down into another group of nodes, and start hacking away at that. So yeah, we have some work to do here. Okay. So the only really challenging thing in here is actually the fact that whenever I initialize a new node, just by how I coded this node class, whenever I add a node, it goes to the end of the list, right? And so if it's the last node that I'm trying to break down into multiple, then okay, but yeah, because it's not the it's not the last one. It's going to take a couple more tries. So I think what I want to do is just paste another sort of group in here. So and and break down downwards, okay? And we'll see how that looks. So anyhow, let's try. Yeah, let's try that. And let me see what's this. Oh yeah, right. So yeah, and I had already. So this is going to be a short episode because apparently I've already coded everything. Anyhow, yeah, we want to walk through the grandchild for every new group that we've created. So this function is first and foremost breaking by commas. Okay, so let's docu that. Break by commas. Um, uh, create fields, or rather populate fields, right? So with every value that we've splitted, whenever we found a comma, we just save those values and then just initialize them. So what we do is the value by separated by commas would be at this node. We replace the value of that node with just an indicator. This is a field. And then all the comma separated values, we just put them right there. So we already have that. Now let's walk that down. And for each field, we want to... this is a bad idea. Where is it? For each field, what we want to do is break at the delimiters. So a little bit of a bad idea on my part, but what I'm doing here, if you cannot read regular expressions, that's fine. So this O then CD thing is from right here. And what this is a pattern that will detect ODE is opening the limiter, so it will detect a literal parentheses or a square bracket. And its brother CDE is for closing the limiter, and it will detect just that, right? So it's either these or these, okay? So if we detect that, that, we want to... Give me a second. Right, not break by, break at. So yeah, newsflash, I am not a native English speaker, so yeah. You'll have to just deal with that. Anyhow, what I want to do, and actually what I'm already doing here, is I'm replacing this pattern match by I'm taking this pattern match and replacing whatever is I've matched to it with the same thing, but with spaces on each side. Okay. So what's that gonna do? Actually, let me just fix a bug real quick. So okay, because the way a split works, if we have a literal space and then a delimiter, any delimiter, so if we have this thing first right? So this is our original, right? So this is the OG, and this is the edited one, right? So after we passed it through this regular expression, it will give us this. And so split is going to take this and say, okay, so here we have element 0, and it will correspond to this, and there is nothing, and so this will be undefined. And then it will be all parentheses. And so if this is not defined, we need to drop that first value because it's useless. So with that explanation out of the way, we have our list of values, which each one of these will essentially be its own node. Okay, so I guess that this one doesn't do anything, and what I would like to do is just replace the value of this node. Yep. So grandchild, I'm just going to straight up replace it. I'm going to say it's a group for now. I'll probably use another tag. I'm not entirely sure. But anyhow, this is a group, or a field, if you will. Same thing, or kind of the same thing. And what I'm gonna do is I'm gonna knit a new child for each one of them. So okay. So for my b in values, I could say my value in values, but yeah, why not? Let's say for my value in values. It goes okay. It goes kind of recursively. So anyhow, what we want to do is just knit make a new node, right? So that's knit, and that's for init, and that's for initialization, right? So yeah, this is good enough shortening, but I like to overdo, right? I like to overdo it. So anyhow, we'll knit by value, and let's do up to there, and where? Oh, silly me. Okay. All right. So it's broken it up more or less the way I wanted it to. So now we have to call Delin break on this bitch. I shouldn't have said that, but well, I've already said it. So yeah, we're gonna call Delin break on this bitch, and let's see what happens. Okay, and as you can see, it does exactly what I wanted it to, and this is a problem. Oh, I get it. Right, so yeah. Okay, so if the result of split as a if the split has a length of 1, that means there are no delimiters, and so then right. So this was not doing nothing. Okay, so it needs to be greater than 1. Okay. All right. So there we go. There we go. So okay, that's that. Now the problem is, I don't know if this will collapse right, but just to check that it does, let me just make this an operation that can be solved, because collapse does not do point to the references. Those are done in the moment, you know, when you're executing. So right, you know, collapse is not going to solve the reference right away. So actually, let's see what happens. Okay, so okay, this is the moment where I feel so stupid that I have to stop and look at what the code is in order to know if it's right, and no, it is not. Oh no, yes, it is, because it's 1 minus 3 plus 2, so that would be minus 5. So 1 minus 5, and that's minus 4. So that's actually correct. You know, people say, like, how are you a software engineer? You have no grasp of basic math. You know, yeah, like, basic math can give me trouble sometimes, but lucky me, I never have to do math in my head because these fucking machines do it for me. Wouldn't you know? Anyhow, so okay, let me show you what subdiv does real quick. So as you can see, it takes the operation itself and then the arguments, and the first argument is 1, again, because the order of the operands matters, at least in some operations. And then the second one is the parenthesized expression. And what happens is we always want to solve the lower levels, right? So the lower it is in the hierarchy, we want to solve that first, and then we go up one level, and then we can solve that, right? So parenthesized expression basically means solve everything within this before you solve anything else. So that's all it does. And so we have to solve this first, and so this is solved, and so now we can solve this, right? So yeah, that's that. So okay, actually that's that. So yeah. So I guess I have to do something about this group thing. I suppose what I could do is because it will be guaranteed that the very first element within that hierarchy will be the topmost operation that needs to be carried out. So what I could do is I could just delete that. No? So I could do the delin break. Oops. And say grandchild. Let me think about this for a second. So what I want to do is say I want to pluck. Okay, so I want to remove the very first node that I have. So grandchild leaves. So that's what we call them, because remember, this is a tree, and so you have a node here. Like, say this is a node, and then its children, because this is a tree, we call them leaves. Children, but anyhow, parent child relationship, same thing, but yeah, leaves. We like to to do those language kind of games. Anyhow, so I want to take the very first child or leaf and pluck it, right? So I want it gone from the face of the earth. But first, I want to take the value within that leaf, or actually the leaf itself. Give me a second, yeah. Yeah, the leaf itself, it's good. Okay. So what I'm gonna have to do is equal I to 0. I'm gonna have to take the leaf itself, and so that would be my child, or I'm gonna say top, right? Because it's the top of the hierarchy, of that subsection of the hierarchy at least. So I'm gonna take that, and then I have to do a replacement of the top level here. So I'm gonna say this is just, you know, I could write a function to do this kind of swapping, but you know, because I can do it manually in a couple lines, I always feel lazy writing this into a method. It would be the way you want to do it, actually. Like, you know, I was reading the other day. No, it's not that bad writing a method, like a short method, if it's something, an operation you do a lot. It will, you know, because you get it right once and that's that, right? So it's not such a bad idea, but you know, like, uh, I'll handle it later, right? So anyhow, we want to put this into top, right? Want to put that into top. And I think that should be that. Let's see. Oops. Not really. Okay. Give me a second here. So there must be an argument for block that I've forgotten. Okay, so that's 867. Oh, wow. Okay. Let me go back here. And what I'm going to do is I'm just going to preach it. So let's preach the tree. Because, you know, because preach. Right, so I was going to do print, but I don't know. I was feeling like being a little bit funky with the naming, you know. Since we're already calling our children leaves. So anyhow, let's preach and quit. Okay. Oh, okay. So I messed up. I messed up. Okay, so I need to copy the children over. All right. That's fine. Right, so before Hmm. Give me a second. I'm just trying to understand the problem. Okay. Ah, right. Right. I know. So what we have to do actually is we have to take this and put it at a later stage, because if you see at this point, right? So at this point we might have more than one children. It's only after we've shuffled things around in the subdiv we can actually do this kind of thing. So what the hell? We should call subdiv right away. No? Why not? Actually, copy this. And actually, this needs to be within this scope. Okay. What we should do is we call subdiv on this thing right then and there. And else we just call the subdiv once again. And I don't remember why I call this one subdiv. I should probably change the name because it's not very informative of what the function is actually doing. But never mind. So after the subdiv, we should be able to pluck like this. And yes, that's correct. So if we don't collapse, you can see that the very first child is first and foremost is only going to be a single child, right? That's a guarantee of this subdiv function. And so we can just eliminate the additional group. And that, you know, that just makes traversal a little bit faster. And, yeah, I think that's that. Yeah, okay. So the thing is done. All right. And there we go. We can solve operations. Okay. So, yeah. Problem solved. Okay. So, fun fact, and it's too bad that I deleted the original implementation of this because it was a whole lot longer, and I said, I can do better, right? Like, I'm not the smartest guy in the world, but I said, yeah, I can do better. I can do better, obviously. And, you know, surprise, surprise, I could. So yeah, the takeaway here is, especially if you're writing parsing code, right? Or an interpreter or compiler or any complex kind of thing. Always look at the, you know, at the simpler way to do things. You know, yeah, I mean, easier said than done, but seriously, because that is the mark of when you know, my coding game is starting to take off for real. You know, because when you look at a problem that's more complicated, you usually over-engineer the solution. Like that's a thing that happened to me all the fucking time. It still does. It still happens to me a lot. But you know, I take a step back and I say, okay, can we do this better? And this time I could. So yeah, the entire as it is now, the entire process of breaking down the expression. So that would be the successive breaking down of this expression into first fields and then discrete operations and all of that. The entire process is now shorter than breaking into fields. So, you know, by these spaces, by these operator-less spaces, it's shorter than it was. So like 3 or 4 operations are now shorter in terms of code size, and probably in terms of speed as well, than the process of just one operation was before. So yeah, you know, I've made the code better, shorter, to the point, and in my opinion easier to read, you know, to a certain extent, and also optimized it. So yeah, you know, it's a win-win. Anyhow, I'm just going to light. And yeah, okay, so that's that. trees. Oh, I didn't do that right, did I? Okay, so because I have a uh, I stopped recording on a shortcut, and I did not press the shortcut correctly, the hotkey correctly. So I'm still recording, and now this is awkward. So yeah, like I was saying, trees. Okay, and that's it for me. Bye.